Welcome to lecture number 5 of fuzzy sets, logic and systems and applications. So, today in this lecture we will discuss various types of fuzzy membership functions. As we know, we have seen in the previous lectures that we can define a fuzzy set by A, which is equal to in the middle bracket x comma mu A x such that x belongs to universe of discourse capital X. So, you see here x is the generic variable, this is generic variable and this is along with mu A of x. So, this mu A of x is nothing but the fuzzy membership function, and this fuzzy membership function is responsible for giving the membership values to the corresponding the value of the generic variable. So, we see here this mu A x is very important in the sense that this provides us the membership values. So, fuzzy membership function is very important in the sense that this function, this membership function assigns the corresponding membership values which are more than 0 up to 1. So, since fuzzy membership value can be more than 0 up to 1, any value in between that, and that is why the membership value fuzzy membership function can be in between 0 to 1, or I would say the fuzzy membership function can go up to at the most up to 1. So, there are some commonly employed membership functions in fuzzy systems theory, and these membership functions are also called standard membership functions, which are listed as the triangular membership function, trapezoidal membership function, Gaussian membership function, generalized bell shaped membership functions, sigmoidal membership function, left right membership function, pi membership function, open left membership function, open right membership function, and S shaped membership functions. So, the details of these membership functions will be described given in the coming slides. So, if we take up first the triangular membership function. So, this fuzzy membership function we define by this syntax. So, the triangle, the syntax here is the triangle and then in the bracket x semicolon a b c, and this a b c, these three are the vertices of the triangle. So, these are the vertices of a triangle, and this is defined by this triangle x semicolon a b c equal to this will be 0 for all the values of x less than or equal to a, and then x minus a by b minus a for all the values of x greater than or equal to a and less than or equal to b. Similarly, this value is equal to the c minus a by c minus b for all the values of x greater than or equal to b, less than or equal to c. And this is 0 when all the values of x, that is this is greater than or equal to c. So, this is how we define triangular membership function. We write a triangular membership function, and here we have an alternate expression for triangular membership function, which is defined by min max function. So, here we take the min of these and this, and then finally, we take max of whatever we get here and 0. So, this is called min max function for triangular membership fuzzy function. So, either of these we can use to generate a triangular fuzzy membership function. So, here you see we have MATLAB code for generating a triangular fuzzy membership function. So, we see here the code, MATLAB code, which generates a triangular membership fuzzy function whose it generates the triangular shaped fuzzy membership function whose vertices are a, b, c. So, a here is equal to 5, b 6, b 7 and c is equal to 9. So, we have basically if we make a triangular membership fuzzy function, it will be like this. If we have, let us say, a here, so a, b, c, and here the highest membership value that it can attain is 1. So, you see here that if this is a, let us say, and this is c. So, it starts from a, goes up to c, and this is the generic variable x is, and here is the membership value. So, the highest membership value here that it attains is 1. Okay. So, the vertex it touches at 1. Okay. So, a is equal to 5, v is equal to 7, c is equal to 9. So, if we use this MATLAB program, we will be getting this kind of shape whose vertices will be at 5, 7 and 9 like this. So, this is 5, this is 7, this is 9. So, if we use this program, MATLAB program, we will be able to generate a shape, a triangular membership function like this. We see here the values of the vertices that are given. So, 5, 7, 9 are given. If we change these values, we will get accordingly the triangular membership function whose vertices we assign here. So, this needs to be noted. Now, we see here the plotted shape that we used in MATLAB. So, if we run this program in the MATLAB, we will be able to get this shape plotted. So, this is the fuzzy membership function, which is this triangular membership function whose vertices are at 5 and then 7 and then at 9. So, as I mentioned before that if we assign the values of vertices, different values of vertices, we can get the different kinds of triangular membership fuzzy functions. So, as we see here, if we assign a is equal to 1, b is equal to 3 and c is equal to 7, it means one of the vertex is one of the vertices is 1 and then the other one is at 3, and then the last vertex is 7 at 7. So, we see this kind of shape gets generated. So, this is how a triangular membership function whose vertices are 1, 3, 7 gets generated. So, by using this program, this MATLAB program, you can generate any kind of triangular membership functions. So, the input that you need to give to this function is only the vertex, the vertices, and accordingly you can get the shape, the membership functions generated. Okay. So, let us now using say MATLAB program, let us give two vertices at 0 0 and the other the third one 7. So, let us see what is happening. So, if we give two vertices at 0 0 means two vertices are at 0. So, we see here these two vertices of the triangular membership function, they are at 0 here and then the third one is at 7. So, we see this kind of shape gets generated. So, this is also a triangular membership function whose two vertices are at 0 and the third vertex is at 7. So, this kind of membership is also called left side open, left open triangular membership function. Alright. So, then we have another kind of membership fuzzy membership function. So, this is trapezoidal membership function and this can be defined by this function. You see here we can write simply trapezoid x semicolon a b c d, and these a b c d are nothing but the these are the vertices. So, if we have these a b c d known and we use this function, we can get a trapezoidal membership function generated. So, this is defined as it is written here that for all the values of x less than or equal to a, it gives you 0, and then for all the values of x less than or equal to b and then greater than or equal to a, it is x minus a over b minus a, and then it is 1 for all the values of x less than or equal to c, greater than or equal to b, and then it gives you for all the values of x less than or equal to d and greater than or equal to c, we have d minus x over d minus c, and then so all the values of x greater than or equal to d, we have 0. And same as the triangular membership function, here this also has an alternate expression for generating trapezoidal membership function using min and max. So, this can be written as trapezoidal again x colon a b c d and then max of min of x minus a over b minus a comma a 1 comma d minus x over d minus c comma 0. So, this is how. So, either of these can be used for generating a trapezoidal membership function. Now, here we have MATLAB code for generating or plotting the trapezoidal membership function. So, in this example MATLAB code, we have trapezoidal membership function with A is equal to 3, B is equal to 4 and C is equal to 8, D is equal to 10, means we have assigned the values A, B, C, D as 3, 5, 8, 10 respectively. And if we run this code, we generate this kind of function. So, you see we have 4 vertices and these 4 vertices are like this, that the first vertex is at 3 and then the second vertex is at 5 and the third vertex is at 8 and fourth vertex is at 10. So, if we change the values of A, B, C, means we can assign accordingly the place of these vertices, and similarly we can change the here if we assign the values of these vertices, we get different shapes of the trapezoidal membership function. Very interesting thing here is to note is that if we make the 2 vertices common. So, means V and C here they are at 5 5. If we assign ABCD values like that, we get a triangular membership function. So, we can use a trapezoidal membership function formula to generate a triangular membership function also. So, what we do here is that we simply have a B and C a common point, means here in this case B is at 5 and C is also at 5. So, with this we are generating a triangular membership function instead of trapezoidal membership function. So, by using this MATLAB program for trapezoidal membership function, we can generate different kinds of trapezoidal membership functions by changing vertices suitably. So, then here we have another kind of plot generated by the trapezoidal membership function. So, if we keep A is equal to 0, B is equal to 0, we see that A and B come at the same point 0. So, here the 2 vertices A and B are here at this point, and then C and C is equal to 3, D is equal to 5. So, we have 2 more vertices at different points. So, here we can make a left open membership function also using this formula, this trapezoidal membership functions formula. Now, comes the Gaussian membership function. So, this is a very interesting membership function, fuzzy membership function. So, this can be defined by a Gaussian and then x. So, this is actually the syntax. So, this is the way we write a Gaussian membership function. So, Gaussian x semicolon C and then we have the sigma. So, C is nothing but the mean, the center, and sigma here is the standard deviation. So, this is equal to e raised to power 1 by 2 and then into x minus c over sigma whole square. So, if we would like to generate a Gaussian membership function, right. So, we can place here the values of generic variable x, and then we can choose accordingly the suitable C, that is nothing but the center or mean and the standard deviation. So, this way Gaussian membership function gets generated. So, here is an example by using a MATLAB code, the Gaussian membership function has been generated, and if you like to use this MATLAB code, you can use for generating a membership Gaussian membership function. So, Gauss MF is the function which is being used here. It is already inbuilt MATLAB function. So, here this is sigma, and here this value is the mean or the center. Okay. So, if we substitute these values in this syntax, the Gauss MF MATLAB function. So, we see this plot generated. So, you see here the center of the Gaussian, the mean of the Gaussian comes at C. So, C is equal to 2, and then we have the standard deviation 0.5, which is used to generate this plot. So, this is called a fuzzy Gaussian membership function. Now, if we change these values, we will get different types of or different Gaussian function membership functions. So, if we change here, see here, if we take C is equal to 5 and sigma is equal to 0.5. So, we get this Gaussian membership function generated. See, the center is changed here. So, now the center is at C is equal to 5, and the standard deviation remains 0.5. Now, if we change the standard deviation, we see the shape of this Gaussian membership function changing. So, this gets the later one has the more spread. So, by substituting sigma is equal to 1, we are spreading the Gaussian membership function. Similarly, if we increase the sigma, we will get more spread like this. So, we see that the center remains the same, center is at 5, but we see 3 Gaussian membership functions with different sigmas. So, sigma is increasing. So, with increase of sigma, the spread is increasing. So, if we increase the sigma, the spread is increasing. So, that is how, if you would like to plot a fuzzy Gaussian membership function, we can very easily plot a Gaussian membership function by using this MATLAB code. Okay. Then comes the generalized bell shaped membership function. So, the formula for generalized bell shaped membership function is here. So, this the syntax of this bell shaped membership function is written as bell x semicolon x ABC, and this will be equal to 1 over 1 plus mod of x minus c over a, and then this raised to power 2b. So, this a here defines the width of the membership function. So, I would say a controls the width of the membership function. That means, the larger value creates a wider membership function. So, larger value of a creates a wider membership function, and b defines the shape of the curve on either side of the central plateau. That means, the larger value of b creates a steeper transition. C defines the center of the membership function, means the either we say center or we say mean. So, here also we have a MATLAB code for generating generalized bell shaped membership function. So, as we saw, the formula for generalized bell shaped membership function, if we substitute the values of a, b and C, we can generate the bell shaped membership function like this. So, we can use the same MATLAB code for generating this generalized bell shaped membership function. We have to substitute the values of A, B and C, and then we will get this bell shaped membership function generated. So, here if we change the values of A, B, C, accordingly we get the different generalized bell shaped membership functions generated. Here also we see that as we change these values, we get different kinds of membership generalized bell shaped membership functions generated. Here also we see by changing these values of A, B, C, here also we get these values, the generalized membership functions generated. Now, we come to another kind of membership function, which is sigmoidal membership function. So, sigmoidal membership function is given by the sig of x semicolon A c, and this is nothing but the syntax of this. So, which is equal to 1 over 1 plus e raised to power minus a into x minus c. So, here also A controls the width of the transition area, and this A here is the A controls the width of the transition area, and C is nothing but again the center of the plot, the center of the transition area, center of the transition area, this is center of the transition area. So, like other membership functions, we have the MATLAB code for sigmoidal membership function also. So, this MATLAB code is given for generating sigmoidal membership function. If we use this MATLAB code and we feed the value of A and C suitably, we can get the sigmoidal membership function generated. So, like in previous MATLAB codes, here also we have a sig mf function, which is nothing but MATLAB function for generating sigmoidal membership function, and x is nothing but the generic variable, and this 4 and 5 are the values of A and C. So, this way if we suitably input these values, we can get the suitable sigmoidal membership function generated. So, for A is equal to 4 and C is equal to 5, you see this kind of sigmoidal function will be generated. This is for A is equal to 4 and C is equal to 5. Now, if we choose another set of A and C, we see that we get a different type of a different sigmoidal curve here, different sigmoidal plot here. So, this plot is for A is equal to 2 and C is equal to 5, and this plot is for A is equal to 7, C is equal to 5. Similarly, we can have other values like this, and we can get other sigmoidal membership functions created. So far, we have discussed the following membership functions in this lecture. So, these membership functions are triangular membership function, trapezoidal membership function, Gaussian membership functions, generalized bell shaped membership function, sigmoidal membership functions, and remaining membership functions, remaining 5 membership functions out of 10 commonly used membership functions we will be discussing in the next lecture. Thank you.